Okay, hello everybody. It's still good morning, isn't it? How are we all doing? I think that's very awake for Friday. I'm very impressed all. Cool. It's great to see you all here. My name is Carly Richmond, and today I'm going to talk about observability, but hopefully with a slightly different slant. Because I am a former front-end engineer who was happy dabbling in back-end services. And what I've come to realize through a lot of triaging incidents and a lot of problems that we need to see all aspects of our application to identify performance issues and bottlenecks. And that means we quite often have to combine tools. And that's what I'm going to talk about today. So I'm specifically going to talk about examples of real user monitoring, OpenTelemetry, specifically web front end and the state that is in. And then I'm also going to talk about synthetic monitoring. I'll do my best to leave time for questions at the end, but if I don't, come and find me afterwards, or we can chat over lunch or at the Elastic booth, okay? So, as I said, my name is Carly Richmond. I actually have changed role again, so I now lead the developer advocate team in DevRel at Elastic. But before that, I worked at Morgan Stanley for 10 years. So a lot of the application of these tools is based on my experience and some war stories of diagnosing issues in production applications there. So every single vendor has some definition on their website somewhere of what observability is. So I went with good old Wikipedia for this one. And what we're going to do with each of these tools is we're going to trace it back to this definition to show what actual state we're going to get hold of and why this is important when we're diagnosing issues. So observability, by definition, according to Wikipedia, is the ability to collect data about programs' execution, internal modules' internal state, and the communication among components. And it's the communication bit among components that we often sometimes miss out, particularly if we are the Java engineer in the team, or we are the JavaScript front-end developer in the team. Sometimes we just focus too much on our tiny piece, not realizing that with the interconnections in complex systems, especially if they've got microservices, especially if those microservices are not so micro, we end up in this situation where we can't really see what's going on. So I have had the experience of relying on logs. I'm old enough to have to log an SSH into the box to try and find it and grep through and try and find errors. I was speaking to someone at the booth the other day who has to download them. So we're still having this situation. But the fact of the matter is it's not enough. And it's not enough because I've had to deal with all sorts of issues relating to performance where I need more information than just logs. I've had applications that are slow and I can't figure out where the slowness actually is. Is it front end? Is it back end? Is it database? Is it somewhere else? I've had to deal with issues where one user's having a random error and it was down to using Internet Explorer. Does anyone still have to support Internet Explorer out of curiosity? There's no hands. Sanity is restored. It's all good. But I've also seen other factors pop up, out of memory issues. I've seen people having issues based on their location. You know, all these factors, you're not going to get them from logs. It's not enough. We need more information than that. Now, quite often we talk about the 3 pillars of observability. Has everyone heard of the pillars? We have. I don't like this definition. It feels very white papery to me. So we're going to change it, and we're going to use the CNCF OpenTelemetry definition of signals instead. Because this makes more logical sense in my head, because what these are is 3 different types of information that we can use to understand what's going on within our applications. So we all know logs, because we've just talked about them. These are these structured messages that we, hopefully, are adding to our application that get sent somewhere to an elk stack or wherever it is that give us information of what's happening, what the errors are, all that kind of stuff. But I need to know about the front-end ones too. And sadly, quite often they just get spat out to the console, and you need to look in the dev tools within the appropriate browser to see what's going on. And now if you were like me, where your users are internal and literally I can walk down a couple of flights of stairs, that's fantastic. But we're not all in that situation. That's actually quite rare if you think about it. Most of us are building applications with external people in mind. So you're not going to be able to really phone them up and say, by the way, can you open up the Chrome DevTools for me and show me what's going on? And then have horror when you see the Internet Explorer sitting in front of you. We don't always have that luxury. The second type of signal is metrics. Are we all familiar with metrics and what these might be? I've got some hands. That's cool. So for those who are not, I'm talking about quantifiable values. So if we think about this in the Java ecosystem, the kind of stuff that I'm talking about is, what's the state of my heap looking like? Is that changing over time? Am I getting quite close to the defined limits in my application? Is it perhaps the situation where I might end up at some point with an out of memory? Was that happening at the time, when the entire service fell over and users suddenly couldn't do something, which I've had happen to me before? But also state of things like your thread count. All these factors are important. But when it comes to front end, we have a different set of measures, and we need to track these too. So who has heard of Core Web Vitals? Can I have a show of hands in the room, please? It's kind of what I expected at a Java conference. It makes sense. But we still need to know about these. So, as the big G suggests, Core Web Vitals, pioneered by Google, initial set were announced in May of 2020. It's gone through various different changes since then. But what these can help us with is looking at identifying bottlenecks within the front end as a quantifiable measure that can be captured in numerous ways. It can be captured through a tool called Google Lighthouse. Has anyone heard of that? A few of us, cool. So you can use it in your browser. You can use it in CI plugins, which is really useful for seeing if the delta changes over time. Maybe you've added in a change that suddenly one of these metrics goes through the roof and you probably want to fix it. But also because they give us an indication in relation to key user activities, we can see what the quantifiable impact is on them. Because at the end of the day, the person that's going to be dealing with the performance issue is the user ultimately first before it even gets to us. And if they're getting frustrated and annoyed that they can't do what they want to do, they're going to go somewhere else. They're going to use a different tool. You're off to the competitor. So, since we didn't have that many who had knowledge of Core Web Vitals, let's go through these. So the first one is called largest contentful paint. And the idea of this measure is it's about the initial loading time, which, think about the applications we use on the web, okay? How many of us have got annoyed when an application just seems to be spinning and taking forever at the start, and we're like, I think you're down. I think there's something wrong. I'm going to go away and come back later or use something else. This is what LCP is all about. It's the render time in the largest image or text block visible in the viewport. And ideally, with our attention spans, under 2.5 seconds is the range in which we want to be. Now, quite often people will talk about first input delay, and I'm telling you to forget about first input delay. It was deprecated last year. And one of the limitations of it is the fact that it was the first. The first is key to this. The first interaction that a user's making, it's basically that time span. And if we think about how complex web workflows are, just knowing how long the first interaction took to respond to a user input is not helpful, because we want to know about all of them, right? So that's why it's been superseded as of March last year by interaction to next paint, which is the longest duration of all these click, tap and keyboard interactions within the page. There are outliers. If you're interested, see web.dev, great resource on web performance, and it covers a lot of these metrics in detail, including this particular article, which dives into the detail between IMP and FID, which is very useful. And ideally, we want it to be under 200 milliseconds, otherwise we end up with the key mashing. Is anyone a key masher like myself? Surely there's more hands than that. Anyway. Now, the last one is cumulative layout shift. And the first time I saw this, I didn't understand why this actually made sense to capture as a measure until I thought about two things. One, I like cooking, and I am getting tired of these websites where I have to scroll all the way to the bottom, skip through ads and the life story of the cooker to get to the actual recipe, which is the first way where this manifests. And the second way is it's actually more likely to encounter user error. So if we all had the situation where maybe the state changes without realizing, maybe the order of elements flips, maybe the buttons change and we end up clicking the wrong thing. This is cumulative layout shift in action. And what we do is we take all of the layout shift scores, figure out how much the page is changed by, and then we take the largest burst ratio, and that's where we get. And ideally, you want a stable page to not move a much, 0.1. And we can use these captured against not just synthetically, but also against live traffic too, using particular tools. And that allows us to understand if there's particular performance bottlenecks within a web application. There are other measures too, so page load would obviously be a quite obvious one. Knowing how long it takes a page to load kind of makes sense. And an extension to that would be time to first byte as well, which is the time for a request and resource to get the first byte. And then traces is the last one. So who's familiar with traces? Show of hands. More people than metrics. That's interesting. OK. So we're not going to... Basically, we know what traces are then. This notion of a parent-child span, obviously available in OpenTelemetry and other tracing technologies that allow us to see the pathway through. But the thing that's important is when we're trying to figure out, is it front-end or is it back-end, is I need to be able to connect these signal types together. So in the example that you see I've got up here, obviously I've got the UI web component, which is my primary page, showing how long that call is taking total. But I can see actually in comparison, the time taken for the Java service to return the appropriate information is actually comparatively a lot smaller. And these are important because each span has the notion of a time span of how long it's taken. I can see what's been going on. But the thing is, in front end, we've still been dealing with this for a long time as well. It's just been manifesting in a different way. So being able to see the request response layouts corresponding to page load, as we've just discussed, would obviously be the way in which that manifests. So I hope we don't have queasy stomachs after last night, because it's time to crack out the rum. So I'm not talking about the favourite beverage of pirates. I'm talking about real user monitoring agents here. And what they are is basically a dependency that you include within a JavaScript application that's going to capture the things I've just been talking about. It's going to capture core web vitals, page load stats, spans, and also it'll capture errors from the console as well. And it will basically send it to the appropriate provider so we can see what's going on in the front end. And also, you can quite often connect them with the back-end telemetry as well. I am using the Elastic one. RUM agents are quite an interesting situation. There's tons of them available on the market, but you tend to have to use the one for the appropriate vendor. So my advice is go have a look at that first, and we'll talk about OpenTelemetry and where we are with that as well if you're looking for an open alternative. So what this allows us to do with a RUM agent is basically we can collect information about programs execution. We can get a bit about internal state, but to be honest, not that much. And then also communication between the components as well. So it's demo time. So I have, can everyone see this okay? Perfect, thank you. This is my sample toy app. And all it does, it's very simple. It's got a Java backend and it's got a Svelte front end. I was playing with Svelte for fun. If anyone wants to come chat about Svelte, come and find me later. And all it does basically is I've got the ability to go through and find records. I can actually search for things. So if I look for Beat, it's going to go and find stuff by the Beatles. If I take it off, then obviously it doesn't. I've got pages for events and news, which do not have anything exciting. And then I've got a subscription option, which is triggering alerts. So a very basic toy, okay? To instrument with a RUM agent, it needs to be added to the entry point. So if it was React, we've been looking in the app.js. Here, we're looking at the top page.svelte. And when we initialize the agent, similar to OpenTelemetry, as we'll see with the other example, we need to specify resources. So once we've installed it, what we need to do is specify the service name. So think back to that notion of multiple services, right? You need to know where the signals are. It's not useful to have just unknown for everything. So you need to specify a service name, or if we were thinking about OpenTelemetry, we'd be talking about a resource. Server URL is obviously the deployment I'm going to be sending this to. And version and environment are actually quite useful attributes that we don't think about when it comes to diagnosing issues. But a quick show of hands, who's had to, within the last maybe couple of months, trace through and see, right, this new error's appeared. Was this in QA or UAT before when we tested this? Has anyone had that? Yeah, okay. So obviously, environment can be an important attribute there. Or what about when you've just put a change into production, you're like, I don't think we saw that prior either. Was that in the prior version? These attributes are actually quite important. We need to have this additional information. And I know this is not just me, because I was literally having a chat with my husband who had the similar problem about a month or so ago. So I know that this is not just me. But the other thing is we need to be able to correlate these things. And this notion of a trace parent header in HTTP under the W3C specification. And that's where this distributed tracing origins option come in. You need to be able to correlate together, irrespective of whether you're capturing backend with OpenTelemetry or whatever. You need to be able to correlate the front end and the back end together so we can see what's going on. And that's where that attribute comes in, because the trace parent header will basically include the backend origins so that any platform is going to be able to kind of suck and establish those connections together. Obviously, if you're using pure OpenTelemetry, you have the concept of baggage, which we can talk about later, but you also have the parent and child span, which can be used to build the picture too. Right, so when we do that, what kind of stuff are we going to get? Well, this is the dashboard here. So here you can see, obviously, page load stats and metrics. Here's the core web vitals. Now, how this differs compared to Lighthouse, for the people that put their hands up before when we asked about Google Lighthouse, is that Lighthouse is generating based on synthetic traffic. It's not based on real live user traffic like this one is here. But we also have the notion of page load distribution and views. Now, views is useful because I've had the situation of I needed to decommission stuff and I needed to know if someone was actually using it. And despite the fact they told me they weren't, they were. Like, on a bank holiday in the States, so like some so minor day that I probably wouldn't have been able to guess the right questions to ask. But also we need to think about the reach of the applications we're building. So for example, if we're building global applications, we need to think about, think about the network, the latency, the bandwidth aspects in other parts of the world. We need to actually know how long it's taking because while we're blessed in the West with fantastic infrastructure, there's other parts of the world that are not. And if you're building web applications for that part of the world, you need to be able to see the page load throughout that too. Along with, going back to my Internet Explorer story, what browsers are being used. And all this user agent information is useful to see alongside the propagated spans between which I have an example. Where's it gone? I promise I had an example. Is it here? This is where we test the demo. There we go. So you can see the propagation there. And also errors. Something happened. Oh dear. So let's move on to more open technology, shall we? Oh, actually, before I do that, I want to talk about a couple of other things. So we've talked about the initialization. Why? Aha, that's why. There we go. So I don't need my extra special slides because the demo worked. The demo gods are happy with me. So let's move on to this. So other couple of considerations that come to RUM agents is sometimes we don't want to touch the JavaScript code because it's a really old aging application, maybe written in Angular 1 or something even later than that, earlier than that, and we're a bit scared of it. So you can use script tags for adding these things in. But we also need to think about frameworks. Do we need extensions? Because all frameworks behave differently. They all handle server-side rendering differently. They all do different wacky stuff. So be mindful of extensions. And then with any performance tool that you add in, make sure you're optimizing your build correctly. So with RUM agents in particular, in fact, and JavaScript in particular, if we don't optimize our production build properly, we can have this really weird, ironic situation where the tool you added for helping you with identifying performance bottlenecks causes performance bottlenecks in your initial load time of your app to go through the ceiling because it's like, hey, I'm taking longer to load this JavaScript file. So let's not do that, shall we? Right. OpenTelemetry. Who has heard of OpenTelemetry? Good. So we're going to go through this. We'll probably not. So who uses it in Java, actually? Because that way we can tweak the demo slightly. OK, half the room. So we'll glide through that. What about the web stuff, the front-end web stuff? We've got one person, no pressure. Right. So we're going to focus on that, which is cool. Right. So this is the example architecture I'm going to walk through today. So this, I've got the Svelte app configured with OpenTelemetry Web SDK. It is going via a proxy to add the cross-origin request headers. Otherwise, nothing's going to get sent, and I'm going to have CORS errors everywhere. And we don't want that. And then I'm also sending it through a collector as well. So obviously, collectors allow you to kind of configure in an agnostic way where to send to the appropriate backend in OpenTelemetry. But I've also got a Java example, which is just going straight into Elastic, so nothing exciting. And OpenTelemetry is an open standard, CNCF-sponsored project, and has the ability to collect actually a lot of the things that we want within the observability space. But we need to talk about some of the caveats before we dive in here. So this is the OpenTelemetry documentation, and there's a couple of things that we need to obviously call out specifically. So firstly, it has implementations for Node.js in the browser, which is what we want. If we're doing full-stack JavaScript development, we kind of need to have both. That makes sense. We need to caveat that it depends on the SDK within OpenTelemetry as to whether it is production ready for all the types of signals that we're talking about today. So what you can see here is actually traces and metrics is considered stable. There we go. But logs is still in development. So obviously capturing those errors and console messages is something we might need to caveat. And then the final thing is this big red warning at the bottom. Warning, client instrumentation for the browser is experimental and mostly unspecified. So what we're talking about now is probably not something I would recommend you go and add to your application in production on Monday unless you want a nasty call with your boss. What we're talking about is obviously a more future place where I'm hoping we'll have front-to-back telemetry and we can add in and basically pull out these types of signals using OpenTelemetry and have democratized data collection on the front end and the back end, which would be a really nice place to be in my view. Now, it is happening. There's a special interest group that are covering this at the moment, and they are including things like they're implementing page view instrumentation, a Core Web Vitals plugin's under development as well. So this stuff is coming, it's just not there yet. But we can also combine it with the Web Vitals library, and this is one of the things that I'm going to show you. So, can everybody see this code okay? Cool, good. If you can't, come and find me afterwards and we can dive through it again. Right, so I will show a QR code at the end so you can go and find the repo. So don't get too scared about all of these packages that I am using on the front end. The main thing that you need to realize and know about is the web trace provider. We're going to create a provider which is going to be the main registered SDK basically that we're going to use to capture the telemetry information. We also have this notion of instrumentation. So an instrumentation is basically the different types of information that we are going to collect. So I've got the document load instrumentation here. 3 guesses what this captured? Well done, document load. Okay, good. What about user interaction? Yeah, events, clicks, hovers if you want to bombard your backend, all those kinds of things. Cool. There is also the auto instrumentations as well. Zone Context Manager. Is everyone familiar with Zone.js? So used very heavily in a lot of front-end frameworks, basically responsible for a lot of the kind of asynchronous collaboration stuff in frameworks and causes headaches from time to time as well. We're going to have an exporter as well in OpenTelemetry protocol format. And then we've also got the browser detector. Hi, can you hang up the phone, please? Thank you. Browser detector here, and also the concept of baggage. Now, I know we all have baggage, but I'm talking about baggage for the correlation later with the Java backend signals, okay? Cool, right. So, first things first, we need to create the resource. Remember what a resource is from our definition? This is going to be our front end at this point. So I'm going to combine it with the detector by merging it with the resource that I'm creating from my own attributes. And remember I talked about the importance of these additional attributes, version and environment, and other things that might be important to you. You can add those in as well. Since we're going to be sending to our proxy, I'm going to use the OpenTelemetry protocol exporter. An exporter, it does what it says in the tin. We know what export means. It sends data out somewhere, so that's what it is. And it's actually sending it to my simple proxy, which is here, which actually is adding the appropriate CORS headers so that I don't end up with CORS errors everywhere, which is a nice thing. Cool. Then what we need to do is register the processor. So you can actually register multiple, and here what I've done is I've registered the trace one for OpenTelemetry protocol as well as one for the console. And then I'm also adding in that baggage propagation under the registration, okay? And then when I create a singleton instance, the way that I start things off is I register the instrumentations I want to capture. So I've got document load, I've got auto instrumentations as well, and I've got user interactions, and I've only captured click. I thought adding hover or all those other ones might be a bit overkill. We're just going to look at click today. But one of the things that we don't quite often look at is we can create our own instrumentations on our own if we extend the appropriate base. And here's an example here that I have where I've created my own Web Vitals instrumentation using the JS library. So you can see here from the JS library, for Web Vitals, I am basically capturing the events for the main types of core Web Vitals that we've talked about. And I define my class with my base here. And what I have is a helper that will report the appropriate tracing. So it's creating a span for each of these and setting the attributes. Ending spans is important, like any resource. And then you'll see that on the capturing event for each of the metrics in the Web Vitals library, I'm asking it to report, and I've reported all changes, just because otherwise it will basically report the first one, or it might be quite specific with the navigation types and things like that. Okay, is everyone with me so far? Nods are good, cool, right. So let's go back to this little toy example again. If the demo's been working in the background, we can see the information that's coming back via OpenTelemetry web. So you'll see I've got my latency and throughput, and it's refreshing every 60 seconds. So the Wi-Fi gods are being nice to me today. I can see the dependencies that are coming through, including references to images, which is obviously quite useful and important. That click event is coming through, which is great, and I can see how long it's taking. But also I can see other metadata, which is quite important and associated with it. So for example, if I want to see if a user's actually, if I'm getting so many button events and I need to know which one is being triggered because I want to see if a feature's actually being used, then being able to see the actual XPath expression of what element in the page is triggering it is actually quite important, along with other useful attributes as well. So things like the browser. You know, believe it or not, we need to still see if people are using aging browsers, you know. A new Internet Explorer is just out there waiting for us. Right. We also have the propagation. So remember I talked about this concept of baggage and the fact that we actually need to be able to correlate and join things together with the Java backend instrumentation. Here's an example of it right here. So one thing that I didn't show you, since a lot of us did have experience, is that I actually have an example here of auto instrumentation. So here's an example of the attributes that I've specified. So for those who haven't used OpenTelemetry, I've specified the exporter in the Java application for traces, metrics, and logs. I've got my endpoint and headers. You're all lovely people, but I'm not showing you my keys. So this is an example. It's not my API key. Don't go try. I've got my service name, and then the resource attributes are those additional pieces of information. And then if you want to do additional instrumentation on the top, you can register the bean, as you can see here. And that means that irrespective of whether I'm doing manual or automatic instrumentation, I can add in my own additional information. And this is useful if there's particular events and attributes that you want to try and pull in. You know, maybe it's not PII information. We had an interesting chat with someone yesterday. Please don't send PII information in your OpenTelemetry attributes. But you can obviously add in these appropriate attributes as well. Okay, so that's how we end up with things correlated together. Now, this is another example of manual instrumentation. No, this is my other examples here. Cool. So we're going to skip through this. And we're going to talk about the OpenTelemetry dashboard. And we're going to talk about automatic versus manual. Cool. So the other thing that I didn't show you is those Web Vitals coming through. So obviously I'm creating custom spans here. So it's not going to go into the RUM agent dashboard because the contracts are different. But I can still have a dashboard that shows me the useful information. So here I've got my LCP, IMP, and CLS values for different types of navigation type as well. So you'll see navigate and reload being key examples, alongside the classifications, and each of them trending out over time. So it's actually quite easy to build a dashboard on top of this data and then go off and show what's going on. And you could potentially have this do smart things like compare across environments or all those other kind of really useful things that we're talking about. Is everyone with me so far? Perfect. So obviously, automatic versus manual instrumentation. One of the things I commonly get asked is, well, Carly, why should we use one or the other? And it honestly depends on the amount of control and whether you want to get really fancy custom implementation views of exporters, in my view. If you want to create loads of wacky, interesting meters and send them out all over the place, then maybe automatic instrumentation gets a bit too complicated. But I tend to recommend start with automatic And then if you need to add on top, you can. Because even with an automatic instrumentation, as was shown with the example, you can still add custom spans if you so choose. Right. And here's the example here that I was talking about. So it's very similar to the front end. That's the thing. All these contracts are the same because the conventions are the same. So in Java, we're still creating providers and meters for the metrics, and then we're registering and building it. It's just it's idiomatic according to the language that we're using. Right. Synthetic monitoring. Who uses synthetic monitoring? Nobody. Oh, one person. Good. Cool. So for those who don't know, I'm going to disappoint you. I'm not talking about having the lovely Pepper here in like some like 80s sitcom fashion help you diagnose issues in your application. As cool as that is, that's not what I'm talking about. I'm talking about, historically, where we use automated scripts running on a schedule to identify issues in production and hopefully catch it before a user complains. That's the hope anyway. Now, in terms of looking at synthetic monitoring as a general construct, it collects data about program execution. If you're wanting detail of internal state, you're not going to get that. That's what OpenTelemetry is for. It's also not really going to give you an indication of component. It is the execution state. It is, are you alive or are you not? So historically, you might have done something like this without even realizing it's synthetic monitoring. So how many people have a script that they've written at some point to ping maybe the health endpoint on a Java service to say, hey, you're alive every 3 minutes. Great. No one's going to give me a call. It's good. That is synthetic monitoring, traditional synthetic monitoring. But synthetic, and that's fine, we still need that. We still need to know that our Java services are alive. But we also need to think about the user perspective because the workflows within our applications are complicated and users do clicks and text entry. And we need to be able to see that those things are not problematic as well. And for that reason, synthetic monitoring has evolved where we have the user actions, clicks, text entry are able to now be captured and we can run the same scripts on a schedule to see if things are alive or not. Now, there's normally 2 different patterns when it comes to capturing these. You can either use recorders. So there's tools for things like Playwright, for Cypress, etc. If you think about traditional end-to-end testing, where we can record these and it will spit out a specification in that format. But given most of us are developers in the audience, I'm hoping we'd like to just write the code instead, which is another option. So that would be a practice known as monitoring as code. And the advantage of monitoring as code, quite frankly, is that we can treat a monitor as an end-to-end test. Because if you're just creating a monitor, maybe with a simple script example that some of us have done, I hope you've tested it first in non-production. Yeah, there's a reason we're laughing, because some of us probably haven't. But the fact of the matter is, we still, particularly with the user clicks and text entry and things, you don't want to end up overloading the production application, okay? We want to be able to try and manage these monitors in a way that makes sense, much like we do with infrastructure, with everything now. So the way that we need to think about this is we write a monitor that can be tested and validated before it even gets to production. Arguably could be an end-to-end test and uses a common definition. And then in production, you have the situation where you can run it on a fixed schedule and say, hey, the applications are live, or, oh, no, it's not, but thankfully a user hasn't complained yet. So I'm going to talk through an example. I'm using Playwright. So is anyone familiar with Playwright? Show of hands? A few of us. Cool. So for those who are not, it's an end-to-end testing and automation framework maintained by Microsoft. I like it. I've used Protractor in the past. Has anyone ever used Protractor before? Yeah, your face tells me everything because you're smiling at me in that really nervous way of, yes, I have nightmares of using Protractor. I mean, I've used Cypress as well. They're all, well, Protractor, the timeout stuff is just horrible. But Cypress and Playwright I've had enjoyed playing with, but we're going to talk about Playwright today. And then it will, obviously, we're using Elastic as well. Now, if you want to get started with synthetic monitoring, the best piece of advice I give you is look at the automation framework supported with where you're sending your events today. That's the best place to get started, because then you can probably write some reasonable definitions quickly that can embed into your platform, and then you don't have to do that kind of DevOps dance of, we're using this technology, we're using something else, and then have a debate or a fight to the death to figure out whether you use Playwright or Selenium. Let's have a grown-up conversation about it. If it's Selenium, fine. If it's Playwright in this way, fine. So what we're going to have is an artifact that is code that we can run locally, that we can run in a CI pipeline to make sure the monitors work, and then we will be able to run it from wherever we choose against the production web app on a schedule, so every 10 minutes, whatever you've decided, and then obviously we'll process the results so that we can see what's going on. So I am going to dive into my next example and then move my slides so that we talk about this later. So a preview of what is to come. Right, so here is my replicator project. This is the code we're going to go through. And this is interesting because Elastic has decided to log me out right in the middle of my talk. Oh my goodness. I don't really want to. I want you to do what I told you to do. Okay, so while that's figuring things out, this is the little toy app that we are going to instrument with synthetic monitoring. So it's basically a very simple ordering app. I can go to the order page and find the items, hey, and add in elements there to the cart, so this will update. I also have a simple login flow. It's not very interesting. It's a very basic app, okay? So if I log in, yes, I want to log in as me. Thank you very much. Well, that's thinking. Come on. I had this all set up and it was all great and ready for you guys, and it's decided to log me out right in the middle. Oh, the joys. There we go. It's there. No, it was there. Oh, for goodness sake. Right, we're going on to backup slides now. So here is my configuration. Remember I said we want to be able to run this in multiple places. So we need to specify the URL on which we're pinging, right? So here I specified local, because I'm going to run it against local when I want to. But I also can override it based on environment. So you can have the same definition running in multiple places. But you can also do smart things, because one thing that sometimes happens with synthetic monitoring is you want a more expansive set for kind of pre-production environments as a test, and you want to be very selective about production because you're mindful about overloading it and interfering with user accesses. So you can do conditional logic like this, and you can also have the username and password as well. The playwright options allow us to do cool things. So device emulation is important, in case there's poor people out there that are still supporting Internet Explorer. You can do that here. And you can also start to look at different device support as well. So quite often an issue that I would find is that if someone was using my app on mobile, but then if they were using it depending on landscape or portrait mode, or even on kind of, PC or whatever, if the page is cutting off in places, the test will fail because you've not got access to that operation. And we need to be able to capture those within monitor situations as well. Here is the test. Woohoo! So playwright, everything happens with the page object. That's the way to think about it. Unless you're starting to get into the realms of authentication. So if you're wanting to simulate like OAuth 2 requests and things like that, you would use the request payload. But here, page object is what you do all the actions against. So things like, getting by obviously the attribute. I don't recommend using these types of locator. I've been the person that's had these monitors based on ID or class attributes, which are commonly used in styling. So what do you think happens when someone changes the styling of the page, maybe reorders some of the elements around? What do we think happens? Half my monitors break, and then I have to go through and fix them all. So let's not do that. Let's instead adopt the convention that's now kind of permeated through the end-to-end testing industry and saying, look, I'm going to pull out everything by test ID. So in fact, if you start viewing the page source of some of the popular sites that you're using, I bet you money you will be able to find that most of them, or at least a subset of them, will have data test ID attributes somewhere attached to the HTML elements. And that's because they've realized that they need to decouple these two attributes together so that they're not fixing monitors or end-to-end tests all the time. But that's what we do in each of these steps, is we basically perform the user operations, what they're going to do, alongside assertions to make sure the page is in the state we expect. It's basically a test, if we really think about it, against production, which scares people sometimes, but that's A-okay. So here what's happening with mine is I'm getting the login button, I'm checking it's navigated to the page as expected, and then I'm checking that the form is defined. I'm then from there checking if the submit button's initially disabled, because I've not entered anything yet, and one of the most annoying things is if you haven't entered your username or password, or you've missed a field, and then you hit the button and then it goes off somewhere else. So we need to also think about the user experience that we're emulating in the monitor too. Obviously, I'm then checking the button's enabled, clicking it, and then seeing that all the tiles are here. So this is the specification for my basic monitor, okay? Which I then can run locally, just like any other end-to-end test, and publish the results as I've got here. And that will give me, going back to my slides I prepared earlier, in case the demo did not work properly, I end up with stuff that looks like this. I can see what's succeeding and what's failing, which is obviously quite important. And these are going to run an update on every single schedule. I'm able to see what's actually failing within it. And importantly, one of the things I really like is I can see the duration of by each step, not just the total duration of the test. Because I've been in the situation, going back to that huge microservices example, where maybe it's the payment service that's unavailable, or it's one particular service that's slowing down. If you split it properly into steps, you can see and start to diagnose issues of where things are starting to go wrong. But we also have the notion of metrics here as well. So we can start to look for degradation in the individual stages of an application. So I can see my core web vitals right down here, LCP, CLS, all good. But I can also see the blocking and wait and receive time to see what's going on. And then we need to have alerts. So if anyone caught my session the other day, you'll know that I have a fond memory of alerts and a bit of a love-hate relationship with them. But obviously, with alerting and synthetic monitoring, there's an obvious trap we get into, which is we alert for every single time this goes down. And if you've got scaling capabilities within your ecosystem, you don't want to be pinging for every single failure of this particular run. Because otherwise, we're just bombarding people with information, because it's like, oh, it's gone down, I need to check things. Oh, it's back up, magic. We need to be smart about this. So what I normally recommend is with synthetic monitoring, maybe think about what your kind of level of comfort is. How long do you want to keep people waiting for? And then you can use that to tweak how many occurrences you'll be happy to wait for before the error actually triggers, okay? But we also then can do even smarter things on top of the data. So does anyone use service level objectives? Maybe any SREs in? Okay, one person at the back I found. Does everyone know what SLOs are? I see some nods and some service level objectives. Well done, thank you very much. So yes, so what these are is an indication of reliability, popularized obviously in SRE, maybe more likely to see on the operational side. But these are still useful, because if we can tie these to these artifacts as well, we can see what the reliability is. And you can obviously calculate these manually, or some tools have integrations to allow you to do this as well. So all of these options are available to you. So we have talked about logs, metrics, and traces. So who thinks they're confident now they know what these things are? Okay, cool. But we've also realized that we are not talking about pillars anymore, right? We're talking about signals. These are pieces of data that we can use to identify performance bottlenecks within our applications. Obviously, we need to think carefully about retention periods and all these other things, because moving away from logs to kind of this holistic telemetry, we're collecting a lot of data. But it's useful data that we can use in outage scenarios that I wish I had when I was an engineer trying to figure out what was going on. We've talked about 3 different types of tools. Hopefully people still know about queasy stomachs talking about rum. And we've also talked about synthetic monitoring and OpenTelemetry as well, but not just OpenTelemetry in terms of the Java ecosystem, but how we can use propagation with OTel Web and Core Web Vitals library to get a more holistic picture of what's happening in a full stack application. So it has been a pleasure. If you want the code, QR code is there. We do have some time for questions if anyone has any. So does anyone have any questions? Yeah. I'll do my best to repeat it because I don't see a mic running around. Are you talking about OpenTelemetry specifically? Yes, so OpenTelemetry has a concept of sampling. So you basically, it's not taking every single signal, and you can actually tweak the sample rate as well, so that it will basically do smart things of determining how much to actually send, which, to be perfectly honest, I would recommend because you don't want to overload your backend. But that is certainly something that you can do. So you just need to look at the sampling rate, and you can actually tweak that as well. Does that make sense? Cool. Yes? On synthetic monitoring? Yes. There is security things that you need to think about when it comes to like all of these aspects as well. So obviously exposure of things like keys would be one thing you need to think about. So you need to make sure you're using appropriate key management for the OpenTelemetry instrumentation, especially when you're obviously having to specify the key to send that back. On the RUM agent, I did have an interesting conversation with someone, I think it was yesterday, and we were talking about this notion that RUM agents, you normally have to have the plain text endpoint in some implementations unless it can pull in the attribute from somewhere else on a web page. So that's a security consideration. You might want to consider using a proxy or something like that if that's possible. On the synthetic monitoring side, obviously you would be running that within an observability platform that hopefully is making use of appropriate encryption of any attributes that you define as the parameters, which obviously is a consideration, like for the username and password that we walked through in the monitoring example. But you should still be using best practices when it comes to keys. And the other thing I would be considering carefully is, look, if you're doing things like login flows and authentication flows, make sure it's a restricted account that is utilizing. So for example, if we take a payment example, some payment providers allow for what's called a test card for testing environments. And you would want to use that and not like, you know, one of your developer's credit cards, for example, in a synthetic monitor. So when you're thinking about your flows, think about the minimum operations, always adopt principle of least privilege and lock down what the monitor can do. That does obviously come with a trade-off of there might be certain kind of write operation flows that you might not be able to monitor for. But I think that's a trade-off that you'd need to consider because obviously the security is paramount, and also make sure the other advantage of having an isolated account in that instance is obviously if it ends up in the wrong hands, you can revoke it quickly and regenerate a new one. So those are the security considerations that I tend to see, along with the obvious of when you're pushing the definitions from the CI pipeline mode into production, you don't want to be showing off your key then either, so you would use appropriate vaults for that too. Does that all make sense? Yeah. Cool. I think there was another question over here. Yes?
I'm not sure if it's a terminology issue of Mr. Point earlier, you showed ROM.
Yes.
Mm-hmm. And after Java file.
Yes.
But for me, it's more the server side. But do we call ROM? Was this configuration needed to support the browser ROM configuration?
Or are you talking about the distributed tracing origins option that was talking about the Java backend? Yeah, let me bring up the snippet and let's walk through it again. Okay, so where's my code gone? It was here. Yes, so you're talking about this option here. So you don't need this if you don't want to correlate the front-end activities such as the CSS loading and things like that with what's happening on the back end on a RUM agent. Because this is what this is doing. It adds the trace parent header with this particular attribute so it can use to join up the front end and the back end stuff together. If you didn't have this, the RUM agent is still going to work. It's just not going to correlate those signals for you together. But you would still be able to see the page load stats and other info. Oh, so that's the OpenTelemetry example. There's no configuration required on the back-end Java service with RUM. No, that bit was the web. So what you're talking about is this bit here. This is OpenTelemetry. So this is separate telemetry for OpenTelemetry. This doesn't connect. It will correlate with the signals for RUM. That you can do, but there's no configuration required on the back end for the RUM agent to work. It's all front-end configuration. Does that make sense?
Yes.
Cool. Right. Is there any more questions? I'll take one more and then we're out of time. Oh, the OpenTelemetry web you're talking about? Yeah, so the reason I say that is because of that disclaimer that's on the OpenTelemetry site about the fact that it is very much still experimental at this stage. So if I was still working in banking, if I went to my boss and said, oh, I saw OpenTelemetry web at a conference, this looks really cool, we should add this in, you're dealing with an experimental technology. Now, every company is different with risk appetite. I worked in a regulated industry, so experimental stuff we didn't tend to do. Yeah, so you get it. That's kind of more the point. So, I mean, obviously, tracing is still important for applications, and there's all sorts of tools out there. And we haven't even covered some things like profiling and stuff that you could also use in a production scenario to see what's going on. But my advice is, as cool as the OpenTelemetry web stuff is, I wouldn't use it on a production app when you go back to work on Monday, just because it's still experimental and you won't get support for it, okay? Does that make sense? Yeah. Cool. Right, I will let you all get off, but thank you very much, everybody.